Hello again everyone, welcome back to ptet.chemistry channel. This is the start of this section B topical MCQs on section 10.6, which is on carbonyl compound. So that's to do with ketones and aldehyde in this classification. So option A in this kind of question refers to 1, 2 and 3 being relevant to what they're asking. B refers to 1 and 2 being relevant to what they're asking. C refers to 2 and 3, and D means that only 1 is relevant to whatever they're asking. Okay, so these kind of questions are getting more and more popular in the other examination body as well, including IB and the other UK levels by various examination body like ETEXL, AQA, OCR, whatever you name it, okay? In this first question, it's saying that which compound have the empirical formula. Empirical formula is defined as the simplest ratio of atoms in the compound. These are your basic definition, and they can ask you in theory paper as well. CH2O. So based on this, if I check number 2, ethanoic acid is that. So there's CH3CO2H. I need to work out the molecular formula, C2H4O2. Then I can simplify to get the simplest ratio of the atoms. That will be CH2O. If I divide by 2, I get 1. If I divide by 2, I get 2. If I divide by 2, I get 1. Okay, I have to divide by the same number to get the simplest ratio of the atoms. All right, CH2O, ethanoic acid is correct. Methanol is a one carbon aldehyde. So in terms of the molecular formula is CH2O, and you can't simplify that further. So both the empirical and the molecular formula is CH2O, and that is correct. Okay, how about methyl methanoate? That refers to the alcohol bit. That refers to the carboxylate bit. The carboxylate bit comes from the carboxylic acid. So if we draw out the ester, we have this bit, which is the carboxylate, is one carbon, so there's just one hydrogen there as a result of methanoic acid giving you methanoate. Methyl, because you have methanol, so I have a CH3. I don't show the C when I draw skeletal, so it's one carbon there. Methyl from the alcohol, methanoate from the acid. So this is HCO2, CH3. In terms of the molecular formula, it's C2H4O2. I don't need to work it out because if you can see it, it's the same. If the C2H4O2 is the same as the ethanoic acid, then the empirical formula must be CH2O as well. All of them are correct. In fact, you should be able to realize straight away that this is a 2-carbon ester. This is a 2-carbon carboxylic acid. There's a reason why carboxylic acid and esters are grouped together under the same subtopic, because they are what you call functional group isomers, and functional group isomers come under structural isomers. If they are structural isomers, they must have the same molecular formula. Okay, if they have the same molecular formula, they must have the same empirical formula. But what is different about them is, of course, their structural formula. That's the definition of structural isomers. Okay. Moving on to the next question. So this has been a relatively popular question. Not that we are guessing any questions, not that you should be guessing any questions, because an MCQ is your chance to show that you really know what you're talking about. It's really the difference between a great and an excellent student, all right? And it's also the difference between someone who can just scrap a pass to someone who can get a credit. Okay, it really makes a difference. So this one is asking about the reaction mechanism, about an aldehyde and a HCN reaction catalyzed by NaCN. Sometimes you use KCN. You need this reaction to be cold because HCN is volatile. That means HCN can boil off at very high temperature. Usually we keep this between 15 to 20 degrees Celsius. If I'm not mistaken, HCN boils around 30, 35 degrees, if I'm not mistaken, right? I don't have that number on top of my head. There's an aldehyde, so I'll just represent this with an example of a very simple aldehyde. This is called methanol. It's a 1-carbon aldehyde. I will draw dipoles because it's the first thing that any sensible student will do. Okay, So I start by using the first nucleophile from the NaCN or KCN, which is ionic. It has got a lone pair on the carbon, which I will use to attack the electrophilic carbon, the delta plus carbon, and then I'll break the C double bond O. You can watch the full mechanistic explanation on the on the organic chemistry mechanism playlist, or you can watch a couple of these under the carbonyl compound topical playlist on my channel as well, to go through the theory in detail. You give away the 2 electrons to the oxygen, so it's got a lone pair there, and it's got carried a negative charge now. You have a HCN molecule, which is actually your actual reactant. So there's delta plus and delta minus. That's gonna pick up the H, and then that's gonna give away the 2 electrons to the carbon. What you ended up with is this OH and CN. So there's nothing changed with the triple bond CN. From there to there to there, there's nothing changed. You are forming a carbon-carbon bond. You are breaking a carbon-oxygen double bond. You are forming an OH single bond. You are breaking the CH single bond. Okay? And do not forget that you regenerated. You regenerate the CN minus, and they can go on and attack and more of your aldehyde. Okay, and at the very end of the reaction, when all the HCN is used up, you will still get one of the CN minus regenerated, and that's why it's called catalyzed by NaCN or KCN, because you don't ever use up a catalyst. It can be involved in a reaction, but it's not used up in the reaction at all. Alright? Which of them are true? In the intermediate, the oxygen carry a negative charge, so I hope you can see that. I don't want to put unnecessary arrow into it, so there is a oxyanion intermediate. So number 2 is correct. A new carbon-carbon bond is formed. You can see that a new carbon-carbon bond is formed. The last stage is the formation of a hydrogen-oxygen bond, oxygen-hydrogen bond being formed. So 1, 2, and 3 are correct. Okay, you should be able to understand this mechanism fully, not just writing it down from memory, because if you understand the story, you will know what exactly is going on. With this next question, so it's this is a hormone produced during pregnancy. Not that you need to know anything about it. What reagent would give positive results? Okay, identify functional group. Very, very important. Identify functional group. This thing there, that is an alcohol. The carbon with the OH is bonded to 2 other carbon. This is a secondary alcohol. This is an alkene, carbon-carbon double bond. Excuse me. This is a carbonyl, and there's nothing on that side. So this is just a ketone. Do not just call something a ketone without checking the other thing on the side, because it could be carboxylic acid, it could be aldehyde, it could be ester, it could be amide, it could be anything. So you got to check whatever is on the side. This is a carbon and carbon on the side, and it's an alkyl and alkyl, so I know it's a ketone. Alright, the rest of it is just alkane, carbon-carbon, and carbon-hydrogen bond. So if I look at 2,4-DNPH, that will undergo condensation reaction. I hope you know the reaction is called condensation reaction with ketones and aldehyde, and you will get nice orange crystals out of them. Okay, as a result of the condensation reaction, which you should be able to draw the product and balance the equation. All right, very important, part of the AS level chemistry. Okay, aqueous bromine, yes, you got the alkene get decolorized because you can do carbon-carbon electrophilic addition reaction. You learned this from GCSE and also O level as well. So I've written this shorthand is electrophilic addition reaction. You can't do anything with Valence reagent because this is a ketone, this is an alkene, this is a secondary alcohol. None of them are aldehyde. So there's no aldehyde, and it will not turn this blue colored solution into a brick red PPT because this thing does not oxidize any other thing except for aldehyde. 1 and 2 only are correct. That's option B. With this next question, it says which carbonyl compound could be easily oxidized to carboxylic acids, readily soluble in cold water. So there are two parts to it, yeah? Part 1 and part 2. Can oxidize to carboxylic acid? You need primary alcohol, no problem, alright? Or you also need aldehyde. Aldehyde can also be oxidized to carboxylic acid because I just saw the aldehyde there, alright? I can cross out 3 straight away because that thing is a ketone. So when you have a phenyl refer to C6H5. So this is the benzene ring. You will do more of this in A2 chemistry. I guess back then there really wasn't a big distinction between AS and A2. So they do have benzene in the older papers, alright? So if I just abbreviate that with pH. So this is actually benzophenone. Not that you need to know it, but C6H5, this is a carbon-oxygen double bond. That is a 120 degree carbon sp2 hybridized as part of your organic chemistry, as part of your ketone and carbonyl compound chemistry. Okay, so you can't oxidize that because that carbon does not have any hydrogen. So I can cross out 3 straight away. In fact, the only answer must be actually there are 2 possible answers. 2 could still be wrong, right? We are not sure about it yet. Alright. So for option 1, yes, both of them can be oxidized to carboxylic acid. Okay. For option 1, you will get so 3 carbon aldehyde, you will get 3 carbon carboxylic acid, so propanoic acid. For the second one, you get that aldehyde and you can oxidize it to that. Okay, it might not be clear if I don't show the phenyl group because that is the next bit, readily soluble in cold water. Okay, so this bit is only 2 carbons. This bit is C6H5. It's actually non-polar. This is also non-polar. But as you know, carboxylic acid is made soluble as a result of this bit that can form hydrogen bond. This bit that can form hydrogen bond, but this bit cannot. This bit is hydrophobic. People who do biology, you have heard of hydrophilic and hydrophobic. Does not like water. This bit doesn't like water much more than this. This is bigger than this. 6 carbon, 2 carbon. This is not soluble in cold water. It's not readily soluble in cold water. That's why I can cross out 2. Only 1 is okay because of the short chain hydrocarbon. So that's option D. Alright. This is the last question of this 5-question series. So what can we deduce from acrolein? So acrolein has alkene. Okay, so this is about identifying functional group. As I told you, when you look at carbonyl compound, you don't always just look at that. You see that, but you got to see what is next to it. It's bonded to an alkyl. It's bonded to a hydrogen. It's terminal. This is an aldehyde, not a ketone. All right. And it will undergo electrophilic addition. That is correct because of the carbon-carbon double bond, alkene type of reaction. You can check out my topical playlist on 10.2 hydrocarbons. That outlines everything to do with alkane and alkene chemistry. All the bond angles are approximately 120 degrees. That is also correct because this is carbon sp2, 1, 2, and 3 sigma. This carbon is 1, 2, and 3 sigma. This carbon is 1, 2, and 3 sigma. Why did I talk about sigma bond there? Okay, all carbon in this molecule have 3 sigma bond. So we talk about 3 bond pair and 0 lone pair because the carbon in each of these, they already form 4 covalent bond. When you count the covalent bond, you include the pi bond. When you count the sigma bond, which give you the bond pair, you don't count the pi bond. 3 bond pair, 0 lone pair. Think about your valence shell electron pair repulsion theory. If you don't know what I'm talking about, you should really go back to the topical playlist on chemical structure and bonding. There's topic 3. In there, you will see the concept on valence shell electron pair repulsion theory. That's to do with explaining geometry and getting the bond angle. Each of these is carbon sp2. So carbon sp2 is 120 degree trigonal planar. All right. It will undergo nucleophilic addition. That is correct because of the aldehyde C double bond O. which is, polarized like that. And you can refer back to the mechanism that I did earlier. Aldehyde and the HCN, well, these are nucleophilic addition. Nucleophile add onto it. Two things add together give you one thing. That is called an addition reaction. Okay, a nucleophile adds onto the polar CO double bond, so it's called nucleophilic addition mechanism associated with aldehyde and ketones. All three of them are correct. This is the end of this 5-question series tutorials. I hope you have enjoyed it. If you did, please share them with your friends, your classmates, your class group chat, your teachers, other friends, juniors, seniors, whoever else you think might find the contents on my channel useful. Alright, so yeah, thank you for watching. I'll see you in the next video.